Week 5, Lesson 1. Okay, so I'm going to let you read that example. We're going to organize this information into a tree diagram. So the first thing that I'm noticing is that there are 60% male. So if this is 60%, then the number of female teachers must be 40%. All right, again, every branch in a tree diagram has to add up to be 1. All right, and then it says of the male teachers, right? So that means that this is going to break apart into two separate things. 30% teach IB, 30%, which then means 70% must not. All right, again, because every single branch has to add up to be 1. And then it says while 80% of the female teachers teach IB. Okay, so we'll call this IB as 80%, and this not, that's a B, not IB at 20%. Okay, so now that we've got this tree diagram with all of our information, it says that given a randomly selected student is in IB math. Okay, IB math. Okay, so there's two different places where you could have IB math. You could have here or here. So that's the denominator. The denominator is going to be both of those branches. So the top branch is 0.6 times 0.3. The bottom branch is 0.4 times 0.8. All right, and then we want success. So we're finding the probability that the teacher is female. Out of those two spots where I put arrows, the ones that have the female teacher is this branch. So that's the branch that goes on the top, 0.4 times 0.8. And if you break out your handy dandy calculator and you round it to 3 significant digits or significant figures, you should get 0.640. Okay, so now let's take a look at this example. So we've got Lauren, Maddie, and George that work in a coffee shop. Lauren makes 50% of the coffee, Maddie makes 40%, and George makes the rest. Okay, so let's sort of divvy this up. We've got Lauren, we've got Maddie, and we've got George. It says that Lauren makes 50%, Maddie makes 40%, and if George is going to make the rest, that has to be 10% because altogether they make 100% of the coffee. Okay, the probability that Lauren, Maddie, and George spill. Okay, so they spill their coffee. So sometimes Lauren spills and sometimes she doesn't. Sometimes Maddie spills and then sometimes she doesn't. Sometimes George spills, etc. You get this. Okay, so let's put the numbers in. These are their spill percentages or probabilities. Lauren spills 60% of the time, Maddie spills 20% of the time, and George only spills 10% of the time. Now, keep in mind, every branch has to add up to be 100. So this is going to be 0.4, this is going to be 0.8, and this is going to be 0.9. All right, so now that I've got the whole tree, let's see. Given that a coffee spilled, okay, so that means that branch, and that branch are going to be the denominator. So I'm going to have 0.5 times 0.6 for the top branch, 0.4 times 0.2 for the middle branch, and 0.1 times 0.1 for the bottom branch. Okay, that's my denominator. Find the probability it was served by Maddie. Okay, so that means this branch is my success. So it's going to be 0.4 times 0.2 on the top. All right, and again, take out your calculator, make sure you round to 3 significant digits, and you should get 0.205. All right, and I think I have one more example. Yeah, one more example. Okay, and again, I'll let you read it. My tree diagram is going to look, I don't know, similar, I guess. It's going to go top to bottom instead of left to right, but that's not that big of a deal. All right, so first thing, it says in jar A, I'm in the wrong, here we go. In jar A, there are greens from jar A and there are yellows from jar A. Okay, and if I'm not mistaken, this is going to be 8 out of 13 and this is 5 out of 13. Okay, so then you take another marble out, again, still out of jar A. So there's greens in jar A, there's yellows in jar A. Do There's greens in jar A, and there are yellows in jar A. Now, since we've taken one out already, there's only 7 left, and there's no longer 13 total marbles. There's only 12. And over here, if we've taken out 1 yellow, that means there's 4 yellows left out of 12, which makes this 8 out of 12. Okay, now this is where it gets interesting, because those marbles that are taken out of the yellow jar, they get transferred to a different jar. Okay, so jar B is going to have greens. Sorry about that, I just screwed that up. There we go. And yellows. All right, greens from B and yellows from B. Greens from B, yellows from B, greens from B, and yellows from B. Okay, now these numbers, you have to think about what has happened before these branches to be able to answer this question, right? So originally, there were 2 yellow and 6 green. There were 8 marbles, okay? But now, because 2 marbles have been taken out and put into this jar, these are all gonna have a denominator of 10. No matter what in this situation, there are 10 marbles in this jar. But the question is, how many yellows and greens? So like in this scenario, we've added 2 more greens. If you follow the branch down, there are now 2 more greens than this 6. This is 8, right? And you can kind of tell, oh, we didn't add any yellows in this scenario. Okay, over here in the next branch over, right, we've added 1 green and 1 yellow, which means we should have 3 yellows and we should have 7 greens. All right, likewise over here, we've added a yellow and a green, so I believe these are the same as the next branch to the left. And then lastly over here, if you take a look at, let's say this one, this has 2 extra yellows. So if that is 4/10, then this is going to be 6/10. Okay, now again, that's probably the hardest part. Right? Hardest part is getting the numbers correct on this tree diagram. I'm just erasing some stuff that is kind of in the way because it bothers me. Okay, so now that I have this all labeled, let me, that's a 10, answer this question. Find the probability that the marble drawn from jar B is yellow. Okay, so here's jar B with yellow, jar B with yellow, jar B with yellow, and jar B with yellow. Okay, that means there's 4 separate branches that I need to multiply down, right? There are, I'm gonna have to zoom this in so I can write it. Hold on, here we go. There's going to be 1, 2, 3, 4 branches, okay? Each branch has 3 parts to it. So let me pause this while I write this stuff all out. Okay, so now I just have to go down each of the branches. I believe that I started on the far left and had 8/13, 7/12, and 2/10. Those are all the multiplications down one of the branches. And then I have 8/13, 5/12, and 3/10 on another branch. Third branch, I have 5/13, 8/12, and 3/10. And the very last branch, I have 5/13, 4/12, and 4/10. Okay? You're gonna have to break out your calculator, and this is not going to be easy to get all the fractions exactly right. One little negative error or a fraction error. Be able to do this in both fractions, which gives you 18/65. Also be able to convert it to an approximate decimal approximation of 0.277. Again, that is 0.277. That is to 3 significant figures.